Okay, this is another request. Trigonometry in 2D. This one uses bearings, so you're going to have to be patient. I'm also going to be drawing the triangle. The question was for 11B, but I do need the information and the drawing that I make for part A, and so I'm just going to do the entire question. Hope this helps. Charles Lee's Marina, and this is paraphrased from the textbook, sails 10 degrees west of north, sorry for the spelling error, for 1.5 hours at 18 kilometers an hour. It makes a right turn to head 6 degrees east of north for 1.2 hours at 20 kilometers an hour. It's a bunch of things I need to do. Let's first draw. Let's pretend this is the marina. Okay, so it's a little big M. I'm going to sail 10 degrees west of north. So if this is my imaginary north bearing, I am going 10 degrees west of north. So something like that. And this is, of course, let me redraw that better. It is about 10 degrees. Okay, what is this distance? Well, let's do a quick, I guess, unit conversion. My time is 1.5 hours. My speed is 18 kilometers per hour. I was about to write V for velocity. What is the distance? Well, if you remember, this is going back to grade 9 math or even previous science, I guess. Speed is distance over time. This is why speed is always in like kilometers per hour in a car. We are given speed, 18. We are given time, 1.5. How do I get d all alone? I'm going to multiply both sides by 1.5, giving me 27. The distance here is 27 kilometers. Okay. Next, from there, I make a right turn. The boat is here now, right? I'm going to make a right turn, heading 60 degrees east of north. So I'm going to draw another bearing right here. If that is my north, I am going 60 degrees, so something like that. I'm just estimating exactly how far I'm going. So that is 60 degrees. Notice also that's sort of, if this was a triangle that I'm making with these 3 dots, that 60 degrees is an exterior angle with the north as a reference, not anything else. Okay, I'll keep moving. Again, let's see, the time is 1.2 hours. The speed is 20 kilometers. Distance becomes speed times time. I'm just going to do this really quickly. You probably have it done already. 20 times 1.2, that is 24 kilometers. 24 kilometers. Okay. At the end of that time, how far is Charles from the starting location? So what I am looking for is this line right here. Well, how do you get there? A couple of things you need to do. I see that I have a distance, or I have a length. I have a length. If I want to find that, it would be nice if I had this angle because I'm already seeing cosine law to be a potential idea. I also think that's the only potential that I have because I don't have much information in making any kind of side angle pair to use for sine law. So let's figure out that angle. Let's call this theta. A couple of things you need to do is I'm going to use this 10 degrees to help me out. Notice that again, by reference of the north, I have 60 degrees on the outside. I also can say that if this bearing is north, directly north, this dotted line is a perfect horizontal, it's directly south. I essentially, in my head, created parallel lines, which makes this exterior angle 10 degrees. 60 degrees, 10 degrees, what's left over? And by now, at this grade, you should know that a straight line adds up to 180 degrees. So theta is going to be 180 degrees. Take away the 60 and the 10 from the angles here. So this angle and this angle take away, which gives us 110 degrees. Theta is 110 degrees. So drawing a triangle with all the extra information out. I have side angle side, and I'm looking for this distance. I can use cosine law. D squared is equal to 27 squared, 24 squared, minus 2 times 27 times 24 times cosine 110. Bear with me as I plug everything into the calculator. It is going to be 27 squared plus 24 squared minus 2 times 27 times 24 times cosine of 110. It gets me 1,748 point approximately 26. Square root that to find the actual distance. It is about 41.8 kilometers. 41.8 kilometers away. That would be part A. So I'm assuming you got to that point. And then it says, what is the course required to return directly to the marina? Well, being a course, in other words, being a direction, you can give me any sense of that direction. You can give me something based on north, something based on east, something based on south, whatever the case may be. So your answer might be a little different from mine in terms of the solution. But I am thinking, if I know, you know what, let me erase all this so that you have a clear picture. So this is our calculation. Oopsies. This is our calculation. We can use that for later. Okay. I'm also going to erase this triangle because I don't need it anymore. I'm also going to erase some of this other stuff because I don't want it to get in the way of your calculations. Okay, so 110. If I want to know the direction of this red line, right? Because I want to go from my current location back to the marina. It would be nice if I can give them some kind of direction from maybe the south, like south something degrees west, right? You can also say from north, you can give a full bearing using the 360, whatever the case may be. I think if I can figure out what this exterior angle is, I figured out the rest of the question, right? Let's try it. It may not be easy right away because it looks like you don't have much to work with at that angle, but you already know that this is going to be 60. You know that the exterior angle here is going to be 10. You know that on the left side is going to be 10, right? There are a couple of things. You already know this distance. There's a couple of things that we could do. For example, you know that because it's a bearing, a direct line going south is perpendicular or parallel to the direct line going north. So we can say that this angle, using parallel line theorem, is a 60. That is the red interior angle of this triangle plus the little extra piece is going to be a full 60, right? What if I have the entire angle of 60 subtracted by the interior angle of this triangle? That would give me this outer exterior angle as a leftover piece. I think that's one way we can go about it. You might have a different way of going about it. There's more than one way, I'm sure, but that's the first thought that comes through my head. Let's try it, right? So again, that exterior angle is already a 60 thanks to parallel line theorem, going back to grade 9. I am going to make it my mission to find what the interior angle of this triangle is. And frankly, I think I already have it. 27 is the matching angle side pair with alpha. And 41.8 kilometers is the matching angle side pair with 110. So using sine law, sine of 110 degrees ratioed with 41.8 should be the same proportion, same ratio as sine of alpha over 27 degrees. So my goal is now to isolate for alpha. 27 is multiplied to both sides. Sine of alpha is going to be 27 sine 110 divided by 41.8, which gives me sine 10 divided by 41.8, approximately 0.606978, blah, blah, blah. I'm going to keep all those decimals and then round only at the end. Is that right? Once again, 27 times sine 110. I don't want to make a mistake and then do another take on this. So inverse sine of that angle, 37.37 degrees. Okay, let me zoom in on this triangle. Okay, let me zoom in on this triangle. I just said that, oh, I just said that if I have this side of the triangle, this entire thing, which is a 60, and I subtract from using this portion, then what I have left is that portion. And that's all I really need. So let's do it. 60 degrees subtracted by alpha, which is 37.37, is going to be 22.63 degrees. That is the leftover piece. Another way you can say is from the south direction, that angle is 22.63 degrees to the left. If I want to go back to the marina, the I guess the bearing or the course Charles must take is south 22.63 degrees west for a distance of 41.8 degrees, 41.8 kilometers. I'll go back to the marina. Hope this helps. Again, there could be more than one answer to this. I mean, more than one solution, but the answer should have obviously be the same. Hope this helps. If it's still not clear or if you want a particular explanation, please leave a message in the comments of our Google Classroom, and I'll try to address it as soon as possible. Good luck, and I'll see you in the next one.